Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. This is lecture number 2, and as I have said in our previous lecture that we will start from the indicial notation, that we will discuss indices in this lecture. So this is called indicial notation. To write something in the form of indices is called indicial notation. So basically we have two types of indices. One is dummy indices, and second kind is called free indices. So let's start with dummy indices. That which type of indices are called dummy indices. Then let us consider this sum. S is equal to a1 x1 plus a2 x2 plus a3 x3 plus up to so on plus an xn. Now we can write this equation, which is 2a1.1, in this form. This is the compact form of this sum. Now here we have used, to write this in the compact form, we have used the summation sign. This is the summation sign, and we can write these aixi, where I is from 1 to n. Now if you will open this summation, then you will have a1 x1 plus a2 x2 plus a3 x3 up to so on a plus an xn. That your index I is varying from 1 to n. Now here in 2a1.2 we have used small letter I to write the compact form of this equation 2a1.1. so now if you write instead of I j, which is equation 2a1.3, or instead of I you can use the letter m, small m, which is 2a1.4, then you can see that meaning of this or this is same. That if you will open the summation on I in equation 2a1.2, you will have right hand side of 2a1.1, and if you will open the summation on j, you will again have right hand side of equation 2a1.1. then similarly if you will open the summation on m, you will have the same right hand side of equation 2a1.1. so it means that if you will change this index I with any other index, or j with any other index, or m with any other index, result will not be changed, result will remain same. Now this type of index is called dummy index. That our result is independent of the index or the letter we are using for the index, that our result is independent of that index. So that type of index is called dummy index. That if you change the index, the result, there will be no effect on the result. It is written here, the index I in equation 2a.1 or j or m is a dummy index, in the sense that sum is independent of the letter used. That whatever the letter you are using, the result will remain same. There will be no effect on the result. The sum will not change, will not be changed. So this type of index is called dummy index. That you can use any type of letter to represent that. I, J, K, P, T, whatever you want to use, you can use that index. It is called dummy index. Now Further we will simplify equation 2a1.1, this equation, to introduce a summation convention which is called Einstein's summation convention. Here again we have written the definition of dummy index, that if we adopt the following convention, whenever an index is repeated once, it is dummy index, indicating a summation with the index running through the integers 1 to n. That what is a dummy index? An index which is repeated one time, repeated once means only one time, that it is appearing only two times. One time repetition means appearing two times. You can see the equation 2, you can see these equations, this equation, this equation, this equation. I is appearing two times, j is appearing two times, m is appearing two times. That this is the dummy index. It is repeating one time. One time repetition means that appearing two times in one term. So it's dummy index indicating a summation. Then what is further thing is that dummy index, and it is indicating a summation on that index which is running, and the summation is running from 1 to n. That is, your index is varying from 1 to n. It is repeating one time and there is summation on that index. It is written here. There is a summation. It is a dummy index and indicating a summation, indicating a sum on that index, and that sum is varying from 1 to n, 1, 2, 3, 4 up to n. Now, to write this summation, we will introduce another summation convention which is called Einstein summation convention. What is this? This convention is known as Einstein summation convention. Now, what does this Einstein summation convention say? It says that using this convention we can write this sum which is given here in this way. 2a.1.1 2a1.1 can be written aixi. Now you can see that here is no summation sign. See, this is the Einstein summation convention, that we are not using the summation sign. Without using summation sign, we are saying that this is the dummy index and there is sum on this dummy index. That we are not using this summation sign here. That in Einstein summation convention we drop the summation sign. Instead of writing this thing in this way, we are writing this thing simply s is equal to aixi with the help of Einstein summation convention. That if there is summation and dummy index, then you can drop that summation sign. Simply you can write s equal to aixi. This is the same meaning as the equation 2a1.2 has, or 2.1, 2a1.3 or 2a1.4. Similarly, you can write aixi equals to amxm is equal to ajxi, ajxj is equal to anxn is equal to apxp. Keep in mind that we will use small letters for indices. Small letters for indices, and these will be in subscripts. Now let us talk about further about this convention. It is emphasized that expressions such as this, if you have three indices ai, bi, xi, so you cannot define this thing in terms of summation convention. So if you have this type of summation, then you cannot, if you have this type of term, then you cannot drop the summation sign. Einstein convention does not define this type of summation. This type of summation means that we have three times, that we have indices which is repeating two times and appearing three times. So our dummy index says that it is repeating one time and appearing two times. Repeating one times means that appearing two times, and repeating two times means that appearing three times. This is written. This type of thing is not defined within this convention. That is, an index should never be repeated more than one time. Should never be repeated more than once time. If it is repeated more than one time, then you cannot drop this summation sign by using Einstein summation convention. That an index should never be repeated more than once when the summation convention is used. Therefore, an expression of the form must retain its summation sign. If you have this type of expression, then you cannot write this thing equals to ai, bi, xi. That if you have s is equal to summation ai, xi, summation sign ai, xi, then you can write that ai, simply ai, xi, and dropping the summation sign. But if you have this type of thing means that you can see that here I is appearing three times, ai, bi, xi. No, you cannot write this thing equals to ai, bi, xi. This thing is not defined in your summation convention. So you have to write this thing with summation sign. Then you can write a1, b1, x1 plus a2, b2, x2 plus a3, b3, x3, like this up to so on, up to n. But you cannot drop the summation sign. This is further. In following, we shall always take n is equal to by 3. This is saying that Rn is 3, that Ri is varying from 1 to 3. That if you have ai, xi, am, xm, it will be a1, x1 plus a2, x2 plus a3, x3. Similarly, it could be ai, a1, 1 plus a2, 2 plus a3, 3. If this is a1, e1 plus e2, a2, e2 plus a3, e3. Now the summation convention obviously can be used to express a double sum, triple sum, 4 times sum, 5 times sum, 6 times sum. Here is the example of double sum. That aij, xi, xj, that I is repeating 2 times, j is repeating 2 times, so the summation I is equal to 1 to 3, j is equal to 1 to 3, and this thing can be written as aij, xi, xj. That we have dropped these two summation signs by using the summation convention, Einstein summation convention. Yeah, and if you have 3 summations, then you can write a. Similarly, you can drop the 3 conventions. 3 signs, summation signs. Now, if you have this thing, then how can you open this thing? If you have aij, xi, xj, and you want to expand this thing aij, xi, xj. So what you will do in very simple way, you can write the expression. How can you write? First, no, this it has 9 terms. How can we say that it has 9 terms? Because I is varying from 1 to 3 and j is also varying from 1 to 3. So first you will open the summation on I, and you will have, if you open the summation on I, you will have a1j x1 xj plus a2j x2 xj plus a3j x3 xj. Then again you will open summation on j in first term, then plus second term plus third term, and you will have these 9 terms. If you can open the summation on I and j simultaneously, but it is good way to write one by one, to open the summation on the dummy indices one by one. That here we have 2 dummy indices, I and j, because they both are repeating one time. So you can open the summation one by one, then you can easily have the result. You can open the summation simultaneously, it's up to you, but maybe when you open the summation simultaneously, you can have the problem. But it's up to you. Here what I was saying, they have written this thing. Yeah, they have opened the summation on I first, aij a1j x1 xj plus a2j x2 xj plus a3j x3 xj. Now again j is repeating one time here, j is repeating one time, j is repeating one time. So summation on j, and summation on j. Now for simplification, writer has explained this thing explicitly, that it has taken this thing and write here and open j, that you can write instead of first form you will write this, similarly this and this, and when you will add these things you will have this 2a1.9. Similarly, if you have 3 times summation, you can write aij xij xi xj xj. Again, this is the same thing, which is telling that if you have 3 times repetition, 2 times repetition, appearing one index is appearing more than 2 times, then you cannot drop the summation sign. Again, they don't represent that. If you write this thing does not represent this, because here I is 3 times, and you cannot write this thing in this way.